You can always generate output directly through the menu. So just left click on file and you can use this kind of output, or you can just print directly from the menu. Same for the schematic, just left click here, left click on file and export or print. But this is not the best way how you can generate outputs from Altium. There is much better way how to do it. To generate the output, we are going to use something what is called job files. So right click on this project, select add new to project and left click on output job file. Right click on this job 1 output file, left click on save as. Be sure you are saving this file inside of our project directory and let's call it let job. Press left button, save this file. The first document what we are going to create is PDF schematic. So we are going to print our schematic into PDF. In this panel, find documentation outputs, left click on add new documentation, select schematic prints, left click on project physical documents, left click on this schematic prints name and call it schematics, enter. Right click on schematics, left click on page setup. I'm going to leave everything default. I will just change this color set because we would like to print this schematic into PDF in color. Left click on color, left click on close, right click on schematic and left click on configure. If you like, you can keep this default, that's just perfect, or you can change the settings, but it's not usually necessary. Left click on OK. To print this schematic into PDF, we need to make connection between outputs and output containers. So what do you think what we are going to do? Left click on this PDF because that's where we would like to print the schematics, and left click on this circle. This will make the connection between schematics and the PDF. This will tell Altium we would like to print the schematics into PDF. What we are going to do now is we would like to sort this PDF output very nicely. So we would like to have, for example, all the schematics in one directory. Left click on this change, and this is our output directory. If you go into our project directory, FedLevel Academy LED YouTube project, this is the output directory. Left click or double click here, and here we would like to have all the documents nicely sorted. So we would like to create directory for schematics, and all the schematics for all the different variants, they should be placed inside of the directory. So this is the release directory. Now left click here. We would like to create the subdirectory, which is going to be called, left click here. It is going to be called output name. This is the output name, schematics. Left click. And the name of the file is going to be based on the variant. So left click here, and we would like to use variant name. Left click. Okay, perfect. Left click on OK, and let's try to generate our very first output. To print our schematic, just left click on this generate content link. Left click, and here is our schematic. If you have a look inside of our project directory, so this is our project directory, you will see there is this schematics directory, and if you go inside, double click, there is our schematic, and the name of the schematic is based on the variant which we just printed. If you go back into Altium, and if we, for example, print the schematic for different variant, left click here, and let's print the schematic for LED2 not fitted, left click on generate content. Here is the schematic. And if you go inside of the project directory, you will see there is the second schematic inside of the schematics directory, and it is called LED 2 not fitted. That's exactly what we would like to have. Notice the difference between the schematics. Yeah, this is the schematic which we just printed for LED 2 not fitted variant, and you can see Altium automatically creates the schematic where R2 and D2 are not fitted. So this schematic is based on the variant which we specified. And if you have a look on the no variant schematic, I'm going to open it. See, this is the no variant schematic. There are all the components fitted. And same way, you can generate documents for bill of materials, for assembly drawings. You will see all the kind of documents we can generate, especially for every variant of your board. Very, very useful. Go back to Altium, and the next document what we are going to generate is 3D PDF. Inside documentation outputs, left click on add new documentation, select PDF 3D, left click on PCB document. We don't need to rename this, just right click on PDF 3D, left click on page setup. We would like to use colors, so left click on color, left click on close, right click on PDF 3D, left click on configure, and you can use defaults. But sometimes you really would like to go through these settings and maybe uncheck some of these things. But for this video, use the default settings. Left click on OK. Left click into this circle because we would like to print it. Left click here, we don't want to print the schematic. And left click on this generate content link. Now have a look. This is the 3D PDF. Use mouse wheel to zoom in, zoom out. And this is really, really awesome. I really like this document because anyone, even the people who don't have any CAD system, they can see 3D model of your board in standard Adobe Reader. As you can see, this 3D PDF is for a LED 2 not fitted variant, and you can see it also on the bottom. There are no components fitted. Close this. We would like to generate it also for no variants, so left click here and left click to generate content. Here is the second 3D PDF for no variations, and on the bottom there are all the components. Close this and have a look into our output directory. We have new PDF 3D directory, and inside of this directory there are the two 3D PDF which we have just generated. Go back to Altium, and because we are working with these 3D views, let's generate 3D model of our board. And 3D model output can be generated through these export outputs. So left click on add new export output, select export step, left click on PCB document. We don't need to rename this, just right click on export step and check the settings in this configure. Left click on configure. I'm going to leave everything default, left click on OK. And this time, because we are not generating PDF, we need to select this folder structure. Okay, so in the output container, I left click on folder structure and connect it with this export step output. Left click inside this circle. Same as for PDF, we would like to customize how the files are going to be saved. So left click on change, left click on output type, left click on custom folder name, and left click select output name, left click on done. So export step, perfect. Left click on output name, and we would like to use the variant for the file name. Left click on use custom output file name, left click here, and find variant name. Left click on variant name, left click on done. Perfect. Left click on OK, and left click on generate content. To check the file what we have generated, you have more options. A very quick way to check the step files is you can import them into your PCB, or what you can do, you can use online viewer. Just go to Google, search for Autodesk Viewer this. Left click on this first link. You need to register, but once you register, you can left click on this Autodesk Viewer, and you can just drag and drop the file here. So I'm going to open the project directory. I go inside export step directory, and here is our step file for no variant of our board. Press left button, hold it down, and place it into the browser. And let's wait a little bit. Once it is loaded, you can just press left button on your mouse, hold it down, and you can rotate the board. You can have a look, for example, on the bottom side of our board if there are the components. They are fitted because we are looking at the no variation step file. This viewer is a little bit slower on my computer right now, but it's free, so I sometimes use it to check the step files. Let's generate the step file for the other variant, for the let to not fitted variant of our board. Go back to Altium, left click here, left click to select let to not fitted variant, and left click generate content. Go back to the viewer, left click on Autodesk Viewer, open our project directory, and drag and drop the let to not fitted step file into the viewer. Same as before, left button, hold it down, and double check the components on the bottom side of the PCB. There are no components, so that's perfect. Go back to Altium, and the next document what we are going to generate is something what you may need if you would like to manufacture this PCB at home. We are going to use these documentation outputs again. Left click on add new documentation, select composite, left click on PCB. We are going to rename this, just left click on composite drawing name, call it layers, enter. Right click on layers, left click on page setup. When you manufacture PCB at home, you would like to use scale 1. So left click here, left click on scale print, be sure here is 1.00, and we would like to print this in a black color. So left click on mono, left click on close, right click on layers, left click on configure. Here we are going to set the layers which we would like to see in this output. And this is a very powerful feature. You can use it to generate the PDF with any combination of the layers in your PCB. That's why I included this example in the video, so you know how to use it. Double click on this icon here. Let's call this top, and we are going to create the combination of layers which will be used to manufacture top side of our PCB. So what layers we need? We need top layer and the board outline. I'm going to delete all the other layers. So first, left click on the top of a line, press shift, hold it down, left click on the mechanical 30 layer. Press Ctrl, hold it down, left click on top layer to unselect this, and left click on board outline to unselect this. release the control button and left click on remove. Left click on yes, perfect. So here in this top composite print is basically one page of the PDF. So on the first page of the PDF, we are going to have all the layers which we need to manufacture the top layer of our PCB. What is also very useful when you manufacture a PCB at home, you would like to see the holes because you would like to know where to drill. So left click here to check show holes. Left click on close. And let's do exactly the same also for the bottom layer. Right click somewhere here in this space, yeah. So right click, left click on insert printout. This is going to be the next page. Double click on this icon. Let's call it bottom. Left click here, bottom. And on this next page, we would like to have the materials which we will need to manufacture bottom layer of our PCB. So we would like to include what layers? The bottom layer. So left click on add button, left click here, left click on bottom layer. Leave everything as it is. Later, if you like, you can play with these settings, but for what we need, leave everything set to full. Left click on OK. And also we would like to see the board outline, so you know how to cut out your PCB. Left click on add button, left click here, and left click on board outline. Left click on OK. Same as for the top layer, we would like to see the holes. So left click here to check show holes. And also we would like to mirror this layer because this is the bottom layer. When we will be manufacturing it, we would like to mirror the layer. So left click here to check it. Left click on close. And because these are the pages, on the first page we would like to have this top layer, and on the second page we would like to have the bottom layer. So we need to reorder these pages. Right click on the top and left click on move up. Perfect. Left click on OK. To print this, we would like to use PDF output containers. So left click here. We don't want to print PDF 3D. Left click, but we would like to print the layers. Left click. For this kind of output, you don't want to use variants. So left click here and select no variations. Left click and left click on generate content. Let's have a look what will happen. Here is the document. When you print this on a paper or when you print it on a foil, it will be printed in the scale 1:1. So it will have the real size of your PCB. And on the first page, there is the top layer, which you can use to manufacture the top layer of your PCB at home. Here you can see these are the holes and this is the board outline. If you go on the second page, there is the bottom layer of our PCB. It is mirrored. Again, you can see the holes and here is the outline. If we go inside of our project directory, you will notice there is a new layers directory created. If we go inside, there is the PDF, this PDF, which we have just printed. Let's go back to Altium, and the next document what we are going to generate is assembly drawing. In the assembly drawing, we will show position of components on our PCB. To generate assembly drawing, we are going to use these assembly outputs. Just left click on add new assembly output. Select assembly drawings, left click on PCB document. We are not going to rename this, just call it assembly drawings. Now right click on this assembly drawings name and left click on page setup. Usually I use scale mode fit document on page, and we are going to use color set color. So left click here and left click on close. Right click on assembly drawings name, left click on configure. For our assembly drawings, we need to adjust these layers. Double click on this icon in top layer assembly drawing. Double click. Now press Ctrl on your keyboard, hold it down, left click on top overlay, left click on multi-layer, left click on mechanical 1, left click on mechanical 30, release the control button, left click on remove, left click on yes, left click on close, double click on this icon in bottom layer assembly drawing, press Ctrl on your keyboard, hold it down, left click on bottom overlay, left click on multi-layer, left click on mechanical 1, left click on mechanical 29, release the control button, left click on remove, left click on yes, left click on close, and we need to make a few more adjustments. For our assembly drawings, we don't really need this top layer and the bottom layer. The thing is, when we will be using variants, when we will be printing assembly drawing for specific variant, Altium is using this top layer and the bottom layer to show unfitted components. This is the only way how we can nicely show the unfitted components in the assembly drawings. So we need to include these layers, but what we are going to do, we are going to hide everything on the layer. So basically it will be invisible in our assembly drawings. Only what will be visible will be the unfitted component for specific variant. To hide all the primitives on these layers, just double click on top layer and use this button hide. Okay, left click on hide, left click on hide, left click on hide. This way we will hide everything on the top layer. When we will use the variants, only what will be visible will be the unfitted components. Left click on OK, double click on bottom layer, and again left click on hide, left click on hide, left click on hide, left click on OK. And for the bottom layer assembly drawing, we would like to also mirror this layer because we would like to be able to nicely read the text on this layer. So left click here and left click on OK. We are almost ready to generate the assembly drawings. There is one more setting what we would like to adjust. Left click on project, left click on variants, left click on drawing style, and down here we are going to choose how we would like to see the unfitted components in our assembly drawing. So left click on this display not fitted components in draft mode and check use graphics, use meshbox, color red, left click on OK, left click on OK, and now we can generate the assembly drawings. First we are going to print assembly drawings for no variants, so select no variations. We don't want to print layers, left click here, we would like to print assembly drawings, left click here, left click on generate content, and let's have a look. Okay, this is the first page, this is the top assembly drawing, the mechanical 29 layer, board outline. If we go on the second page, this is the mechanical 30 layer, this is our assembly bottom layer. You can see the layer is mirrored, so we can nicely see this text, the component designators, and this is the board outline. Left click, select different variant, left click on let to not fitted, left click on generate content, and now I'm curious. First page is exactly the same, but on the second page we should see the unfitted components, and they should be marked with meshed red box. So let's go on the second page, and here it is. So these two components, they are not fitted. Yes! If we have a look inside of our project directory, there is new assembly drawings directory, and inside there are two assembly drawings printed for different variants. There is also a different way how you can show assembly drawings of your board, and this different method is to create a draftsman document. In draftsman document, one of the things what you can show is, for example, assembly top and assembly bottom drawing of your board, and you can include in this document also different kind of information. And in this video, I would like to include very simple example how you can create assembly drawings in Draftsman. It's very simple. So to create to create a Draftsman document, just hover cursor over a project, right click, select Add New to Project, and left click on Draftsman document. Now press OK. And here we are going to add the assembly drawing top and assembly drawing bottom views. Hover cursor somewhere in this document area, right click on your mouse, select place, and to insert assembly drawing, we are going to use this board assembly view command. So left click here, okay? Left click on board assembly view, and left click to place it somewhere into your document. What we would like to do, maybe we would like to make it a little bit bigger because it's quite small. So to work with objects in Draftsman, you need to select them. So first, left click on this top side view to select it. And then here in this right panel, you can adjust the parameters of this selected object. And to make it bigger, we just need to change this scale, left click here and change it to 4:1. Left click. Press left button, hold it down and move it. We are going to insert the bottom view. Just hover cursor in this empty area, right click on your mouse, left click on select the place, left click on board assembly view, left click to place it somewhere. As you can see at this moment, it is view for the top side, scale 1:1, so we would like to adjust some properties of this object. Left click to select it. First, we would like to change it to the bottom view, so go into properties and in view side, left click here, select bottom, left click on bottom, and also we would like to make it a little bit bigger. In the scale, left click and select 4:1, left click. Press the left button, hold it down and just place it. Maybe you noticed these views, they are not created based on our assembly drawing layer. These views, they are currently created based on information from 3D models. And because we would like to use our own assembly drawing layer, we are going to set it. So just left click on this document to see this properties panel for whole document. And in this source, change the top assembly layer, left click here, change it to mechanical 29, and change the bottom assembly layer, left click here, change it to mechanical 30, left click. Now you need to select this top side view, just left click here, and in these properties, go down, in component body, left click here, select assembly drawing. Watch what is going to happen, okay? Left click here. Perfect. Now it is using our assembly drawing. Do exactly same also for this bottom side, left click in this component body and left click on assembly drawing. Perfect. If you would like to see how the components in these Draftsman, how the unfitted components in this Draftsman are shown, just left click somewhere on this document and here you can change the variant. Left click here and left click on let to not fitted. See, again it is using this mesh. Here you can specify how the unfitted components are shown. It is using this mesh and you can very nicely see these two components are not fitted for a let to not fitted variant. Left click, I will select all variants, left click here, and now they are fitted. Don't forget to save this. Hover cursor over this Draftsman document, right click on your mouse, left click Save As. Be sure you are going to save it into our project directory and just save. Press left button. Yes. Let's go back to our job file. Just left click on this Let Job, and we are going to add this Draftsman document into our documentation outputs. Left click on this Add New Documentation, select Draftsman, and this is important. Left click on this let.pcb Draftsman document. Left click. Right click on Draftsman name. We don't have to configure anything. Left click on Page Setup, and we are going to keep everything default. Left click on Close. We are not going to print these assembly drawings, so left click here, but we would like to see the output from the Draftsman, so left click here. First, we are going to print the output from Draftsman for no variants, so left click on no variations, and left click on Generate Content. Here it is. So this is the nice Draftsman document with our assembly drawing top and assembly drawing bottom view for no variant. Close this. Left click here, select let to not fitted variant. Left click on Generate Content, and this is the second document. Here you can see the not fitted components, they are marked. Perfect. If we have a look inside of our project directory, there is new directory called Draftsman, and inside there are the two documents for different variants. Go back to Altium, and the next file what we are going to generate is a document for pick and place machine. So we are going to generate pick and place file. Inside of assembly outputs, left click on Add New Assembly Output. Select Generate Pick and Place Files, and left click on PCB document. Right click on this name. There is no page setup. Left click on Configure. And as you can see inside of this file, there is information about position of every component on your board. So this information is used by a machine which is going to fit components on your PCB. I'm going to leave everything default, press left button on OK. We would like to generate it as a file, so this time we are going to use this folder structure in output container. Left click here. We don't want to generate this step file, left click, but we would like to generate pick and place. Left click. We are going to generate it for the not fitted variant. Left click here, select no variations, left click, because we would like to see position of all the components on our board, and left click to generate content. If we go inside of our project directory, there is new directory called generates pick and place files. Inside of this directory, there is this text file. It is very simple file. When I open it, this is what you will find inside. Yeah, there are all our components, and here you can see position of the components on our board. Go back to our job file, just left click on this let job output file, and the next outputs what we are going to generate are Gerber files. These are really important to manufacture your PCB. So to generate Gerber files, inside of fabrication outputs, left click on add new fabrication outputs, select Gerber files, and left click on PCB document. Right click on Gerber files name. There is no page setup, so left click on configure. leave this default, left click on Layers tab. We are going to enable what layers we would like to use to generate the Gerber files. So left click on top overlay, top paste, top solder, top layer, bottom solder, bottom paste, bottom overlay, and left click on board outline. Leave this default, and leave this default, press OK. Left click on this generate pick and place, and left click on Gerber files. Be sure no variation is selected, and left click on generate content. To check the files what we have just generated, you can use Altium. You will find the files here, and you can open them directly in Altium. But I normally use different software. I don't want to check these important files in same software in what they were generated. I would like to use independent software just to be sure everything is okay. So what I normally use, I use ViewMate. Just Google for ViewMate. Enter, left click here. They have also free version of this software. You just need to register and download it. Once you download and install ViewMate, start the software. This is how it looks. Then left click on File, select Import, left click on Gerber. Go inside of our project directory, FedDevel Academy, LED YouTube project, output directory, and Gerber files. If you like, you can order the files based on type. These are the Gerber files. So left click on the first file, then press Shift, hold it down, left click on the last file to select all these CAM files. Left click on Import, left click on Yes. If you would like to see what is inside of the files, what we have generated, we can hide all these layers, left click on this button, and here are all the files, okay? The first file, this is not a Gerber file, but the second file is no variation.gbl. That's Gerber file of the bottom layer. And to make it visible, just double click on this layer, double click on this file. So this is Gerber file for bottom layer of our PCB. To hide this layer, double click. To enable the next layer, double click. This is the Gerber file for bottom seal screen or bottom overlay layer. Double click, double click. This is the bottom paste layer. You can see the extensions of the files, okay? No variations.gbp, bottom paste. If I hold the cursor here, GBS, bottom solder layer. So double click, bottom solder, double click. This is the board outline, double click. Top layer, top overlay, top paste, and this is the top solder. To enable all of them, I will disable this and left click on this button. If we have a look inside of our project directory, there is new directory called Gerber files, and here are all the Gerber files which we just checked. Go back to Altium, and next file what your PCB manufacturer will need to manufacture your PCB is called drill file. To generate the drill file, we are going to use this fabrication output again. Left click on Add New Fabrication Output. Select NC Drill Files. Left click on PCB document. Right click on this NC Drill Files name. There is no page setup, just left click on Configure. You can leave all these default settings. Press OK. Left click here, and left click to generate content. open our project directory. There is new directory called NC drill files. Go inside of this directory, and this is the important file. When I open it, inside of this file there is information about the tools what are going to be used to drill the holes on your PCB, and there is also information about position of every hole on your PCB. This is the file what is needed to drill the holes on your PCB. If you would like to check the drill file, you can use this ViewMate. Just left click on the next empty layer, for example this one, layer 11. Then left click on File, select Import, left click on Drill and Route. Go up, go inside of NC drill files directory and select the text file. So left click here. Left click on Import. Now hide all the layers and double click on this drill layer. See, these are the holes what are going to be drilled on your PCB. If you enable one of the layers, for example this one, you can also see they are in the right positions. Go back to Altium, and we are going to generate the last file in this video. Yippee! To be able to generate this last file, there are two requirements. The first requirement is that you need to have Microsoft Excel installed on the computer where you are running this Altium. Maybe you notice I changed computer. This is a little bit different one what I was using. On this computer I have Microsoft Excel, so the first requirement check. The second requirement what you need to be able to generate the file, exactly the same file what I will have here, you need to download the BOM template. I'm going to show you where you can download it. Go to Google and search for Fedevel GitHub, enter, left click here, and the file what we need is located inside of this project, board.let YouTube, left click, or you can directly go on this URL. This is the file what we need. Just left click and left click to download it. Once you download the file, copy it inside of our project directory. That's exactly what I have done. Yeah? Inside of Fedevel Academy Let YouTube project, I copied there the file what I have downloaded, this BOM template file. If you like, you can have a look what is inside of this file. It is standard Microsoft Excel template file. And I'm going to show you what is inside, so you can see. This is how it looks. Inside of this file, you can specify how your BOM, bill of material, is going to look. For example, inside of this template, you can specify what parameters you would like to show in your bill of material. And these parameters, do you know where these parameters are located? These parameters, they were imported from DigiKey when we were creating our schematic symbols. If you remember, when I open Altium, this is our schematic symbol library, and these are parameters of this symbol. These are the parameters which we imported from DigiKey, and these are the parameters which you can show in this bill of material. If you would like to add some columns, or if you would like to change some columns, everything what you need to do is just use this naming for the column, okay? Call it column and put here the parameter which you would like to list. Let's go back into our job file. So left click on project, left click on job file, and to add the bill of material, we are going to use this report outputs. So left click on add new report output, select bill of materials, and left click on project. Right click on bill of materials name, left click on page setup. Usually I do not change anything here, just left click to close, right click on bill of materials, and left click on configure. In this window, we need to enable all the columns which are used in our BOM. And also we need to do a couple of other settings. So first, what we are going to do, we are going to remove this comment and footprint from grouped columns. Hover cursor over footprint, press left button on your mouse, hold it down, and drag it down here, release the left button. Hover cursor over comment, press left button, hold it down, and release the left button down here. We are going to group all these components based on libref. So find libref down here. Here it is, left click here. Now press left button, hold it down, and move it up. Libref is basically the component name, so all same components will be grouped together. This will help you to show, for example, how many LEDs we need on our PCB, how many this kind of connector we need on our PCB, how many these 360 ohm resistors we need on our PCB. Okay, so this means all 360 ohm resistors are going to be grouped together. Then in this part of the window, we can enable and disable these columns which are here. So everything what we need to do, we need to go through all these items. I will use a page down, and I think we don't use comment. If you open our template, here are all the columns which we need, and there is no comment. So I'm going to disable the comment. Then we need to enable case, I remember, case package. We need to enable category. We need to enable description. Okay, description is enabled. We don't need designator, so left click to uncheck this. And also we need to enable quantity. Quantity is already here. Okay, perfect. Now go at the end of this list. Left click here on this triangle, and left click here on this square. Enable all these other columns. These columns, they include the manufacturer information and supplier information which is used here. Few more settings what we would like to do. We would like to order our BOM based on category, so left click here. At this moment this is optoelectronics connector resistors. We would like to order it based on category. So connectors, optoelectronics resistors, perfect. All our BOM is going to be in USD, so left click here and find USD, here it is, left click. Let's say we would like to see the BOM for 1000 pieces, all the prices we would like to see for building 1000 pieces of our board. That's what I normally use. And we would like to use our own template. So here, left click on these three dots, go inside of our project directory and left click on this BOM template. Left click on open. Oops. Okay, left click on open and check this relative path to template, because when you move this project and if you have it in different directory, it's much easier. Use this. Just left click here and press OK. Left click on OK button. Let's have a look if we have set everything correctly. We are going to generate the bill of materials for no variations. Left click here, and left click on generate content. Perfect. Here you can see a list of all the components which are needed to build the NOV variant of our board. One piece of the Molex connector, 2 LEDs and 2 resistors. What is really good is that all the information which you can see here, it was taken directly from DigiKey when this bomb was generated. So for example, you can very nicely see that right now they don't have this LED in stock in DigiKey. Also, what you can see, the price right now for this connector in DigiKey is 0.22. And what is also really good on this bomb is that it shows the prices. It shows how much would really cost you to build 1000 pieces of the board. So it automatically uses the prices which are needed to build, which are needed to buy the proper number of components to build 1000 pieces of your board. Yeah, because there is big difference between buying one piece of your component or 1000 pieces of the component. So this price here is used to buy, is taken based on the information that we will need 2000 pieces of this component to build these 1000 pieces of the board. I'm sure you understand. Go back to Altium and we are going to generate bill of materials also for the variant of our board. Left click here, left click to select let to not fit it, and left click on generate content. Now you can see the difference, okay? This bomb is for variant let to not fit it, and you can very nicely see that for this variant we only need one connector, one LED and one resistor. I'm going to close this bill of materials, left click to close, don't save, left click to close, don't save. And if we have a look inside of our project directory, there is new directory called bill of materials. Inside of this directory, there are two files. One is for NOV variant and the other one is bill of material for let to not fit it variant. That was the last file what we have generated in this video. I uploaded all the files which we created in this video. I uploaded them on our GitHub, so you can download the complete Altium project from here. Just left click on this button and download the zip file. Here are all the step models, here are all the outputs. This is the template for the bomb, and here are also the schematic and PCB files. So on this address you can download the complete project from this video. I will attach this address, I will place this address into description under this YouTube video, so just go there and you will find it there. Wow, I was not really expecting to create so long video or so long series of the videos. When I started recording this video, I was thinking like, oh, let's create like maximum 1 hour video about this new Altium, so everybody knows how to work with or how to work in this new Altium. It's a little bit longer. I still hope you found it useful, and if you like this video, then please don't forget press the like button. Also have a look on all the other videos what I have on the channel. There are a lot about Altium Designer, there are some about Cadence, and there are many videos just about general hardware design tips and tricks. And if you like this channel, if you like to receive a notification about new videos, subscribe. And now you may think like, oh, I don't need to like this video, I don't need to subscribe for this video, because next time I just can go here and watch the video, the new video. Yeah, but I need to say that all your likes and all your subscribers, it just gives me energy. it is telling me that you like these videos, what I'm creating, and it motivates me to create new videos. You know, because if there are no likes, if there are no subscribers, maybe I would just sit down and I would be thinking like, does it really make sense to create these YouTube videos if I don't really know if people are watching it, if they like it? That's why it is important. Please, if you like this video, let me know, okay? Just press the like button, and also leave the comments. It's so really nice to read all the comments what people leave under the videos. Thank you very much for this. Now, if you like this video and you would like to continue, you would like to learn more, then have a look on our website. Just Google for Fedevel Academy. We have some, I have created also a number of courses about hardware design. And if you would like to, for example, design something a little bit more complex than this simple LED board, go into courses, all courses, deals and packages, and left click on this. Learn to design your own boards. This is very similar to, this course is very similar to this video what you just saw, but you will be creating a more complex board. You will be creating the board like this. And you will learn a little bit more about the placement, some tips and tricks in hardware design. You will learn more about the layout. It's very often I say I'm not creating courses to teach about Altium Designer. Our courses are about teaching hardware design. Yeah, Altium Designer is just a tool which we are using to show how to do it. So learning Altium Designer during our courses is actually kind of side effect, but main reason why these courses exist is teaching about hardware design, is teaching you how you can design your own boards. If you would like to design something a little bit more complex, then there is another course, this one, all courses, Advanced PCB Layout course. This is a very popular course. This one, Learn to Design Your Own Boards, and this one, Advanced PCB Layout course. These two courses are really popular. When I left click here, on this Advanced PCB Layout course, you will be practicing doing layout of interfaces like memory layout or some other high-speed interfaces, PCI Express. Yeah, you will be working with this much more complex board with like 12 layers, and you will be doing, I don't know, decoupling capacitor placement under BGA. You will be doing fan out from this BGA. So you will learn a lot of things which will help you to design really complex boards. And that's everything what I wanted to say in this video. So please, if you like the video, don't forget to press like button, and I would like to thank you very much for watching, and see you in the next video. Bye!